Welcome to day 16 of Cloud Techie. In this session, we are going to cover the three protocols that make email trustworthy on the internet today: SPF, DKIM, and DMARC. If you've ever set up email for a company, dealt with your messages landing in spam, or been told your domain needs to be protected against spoofing, these three are exactly what you are working with. Let me set the scene for where this fits. Every email you send travels over a protocol called SMTP, or Simple Mail Transfer Protocol. SMTP was designed in the early 1980s when the internet was a small and trusted network. At the time, nobody built in a way to verify that an email genuinely came from who it claimed to come from. That design decision is still with us today. By default, anyone can send an email claiming to be from your domain, and the receiving mail server has no built-in way to know whether it's real or forged. SPF, DKIM, and DMARC are the three layers the industry added on top of SMTP to close that hole. Here is how we'll go through them. First, we'll look at the core problem itself, so you understand exactly what we are defending against. Then, SPF, which controls which servers are allowed to send email from your domain. Then, DKIM, which proves a message wasn't altered while it traveled. Then, DMARC, which ties the first two together and is the piece that actually stops spoofing. After that, we'll go through real configuration, how to read the reports these systems generate, and the common mistakes that trip people up. By the end, you will understand not just what each protocol does, but why all three are necessary together. Let's get started. Before we talk about any of the solutions, you have to understand the problem clearly because everything else is built to solve this one weakness. When you send an email, your email program writes a from address into the message. That from address is just text. There is nothing in the SMTP protocol that checks whether the server sending the email actually has any right to use that from address. The server that accepts the message and passes it along doesn't verify ownership of the domain. It simply delivers it. So from the screen, you can see that an attacker sets up their own mail server. They craft an email and put CEO@yourcompany.com in the from header. They send it to one of your employees. The receiving server has no information in the message itself that tells that it is fake, so it delivers the email. Your employee opens the email and sees what looks like a genuine message from the CEO asking them to do something urgent, like approve a wire transfer or click a link. This is the foundation of business email compromise and phishing. And notice what the attacker did not need to do. They never broke into any account, they never stole a password. They simply send an email with a forged from line, which SMTP allows by default. This is the gap. SPF, DKIM, and DMARC each take on a different part of closing it, and we will build them one at a time. Let's start with the first layer, SPF. SPF stands for Sender Policy Framework, and the question it answers is this: how does the receiving mail server know whether the server trying to deliver mail for your domain is actually allowed to do so? The answer SPF provides is a public list. As the owner of a domain, you publish a record in your DNS that names every server and service that is permitted to send email on your behalf. DNS, the domain name system, is the internet's public directory that maps domain names to addresses and other records, and anyone can read it, including every receiving mail server in the world. So your list of authorized senders is publicly available for any server to check. So here's a sequence of what happens. An email arrives claiming to be from your domain. The receiving server looks up your SPF records in DNS. It reads your list of authorized senders. Then it takes the IP address of the server that actually delivered the message and checks it against the list. If the IP is on the list, the SPF passes, and if it is not, the SPF fails. Now look at the record on the right, because you'll be configuring a lot of these if you work on the AD admin side. It always begins with V equal SPF1, which identifies it as an SPF record. After that comes the mechanism, which are entries that define who is authorized. The include mechanism is the one you will use most often. When you write include spf.protection.outlook.com, you're telling receiving servers to also trust everything in Microsoft's on SPF record, which is how you authorize Microsoft 365 to send mail on your behalf. The IP4 mechanism authorizes on one specific IP address directly, and the record ends with an all mechanism. So minus all means reject anything from a server that isn't on the list, which is called a hard fail. There is one technical limit you must know about. SPF permits a maximum of 10 DNS lookups when the receiving server evaluates your record, and every include statement counts as one lookup. So if your record chains past 10 lookups, SPF returns a permanent error and fails for everyone, including your own legitimate email. So this becomes a real constraint once you start adding several third-party services. And here is a gap to carry forward. SPF checks what is called the envelope sender, the behind-the-scenes delivery address, and not the from address your users actually see in their inbox. That means an attacker can pass SPF and still force the visible from line. So keep that in mind, because it's exactly why we need the two protocols. Now the second layer, DKIM. DKIM stands for Domain Keys Identified Mail. Where SPF checks which server sent the message, DKIM answers two different questions. Did the domain that claims to have sent this message actually authorize it? And did the message arrive unchanged from how it was sent? So to understand DKIM, you need one concept from cryptography, that is the key pair. A key pair is two matching keys, a private key, which you keep secret on your mail server, and a public key, which you publish openly. So anything signed with a private key can be verified using the public key, but the public key cannot be used to create signatures. So that one-way relationship is what makes it secure. You can follow the flow on screen left to right. On the sending side, when your mail server sends a message, it takes certain parts of the email, specifically key headers like from, to, subject, along with the body, and runs them through a hash function. A hash function turns any input into a fixed length string of characters that acts like a fingerprint of the exact content. So if you change one character anywhere, and the fingerprint comes out completely different. The server then encrypts that fingerprint with its private key, and the result is the DKIM signature, which gets attached to the email as a hidden header called DKIM signature. On the receiving side, the server needs that DKIM signature header. So inside it finds two important tags, the D tag, which names the domain claiming responsibility, and the S tag, the selector, which is just a label pointing to the specific public key to use. So the receiving server queries DNS in the address selector, dot underscore domain key dot the domain, retrieves the public key and uses it to check the signature. At the same time, it independently hashes the message it received using the same method. If its own fingerprint matches the one in the signature, two things are proven at once. the message was genuinely authorized by that domain and not a single character was altered in transit. If anything changed, the fingerprints will not match and DKIM will fail. So now if you look at the header fields on the right, the B tag is the actual signature itself, and the BH tag is the body hash. And the H tag lists which headers were included in the signature. And because the public key only verifies and never signs, it is completely safe to publish it openly in DNS. One last point, DKIM does not encrypt your email. The contents are still readable in transit. So what DKIM provides is proof of authenticity and proof of integrity, nothing more. And that's exactly what it is designed for. Now we need to pause and understand why neither SPF nor DKIM is enough on its own, because this is the entire reason DMARC exists. And if you understand this slide, DMARC will make complete sense. So look at the SPF side first. Remember that SPF checks the envelope sender, the technical mail from address used during delivery, which is separate from the from address your users see. So here is the attack. An attacker registers their own domain. Let's say it's called attackerdomain.com. And they set up a perfectly valid SPF record for it because it's their domain and they're allowed to do, right? They send their email with the envelope mail from on attackerdomain.com, which passes SPF cleanly. But in the visible from header, the part the user actually reads, they write your CEO's address. SPF passed because SPF only ever looked at the envelope. The user sees a spoofed from line. So SPF never checked it, right? Now on the DKIM side, and it's the same shape of a problem. The attacker registers attackerdomain.com, sets up valid DKIMs, signing for it, and signs their message correctly with their own private key. DKIM passes, but because the signature is genuinely valid for attackerdomain.com. But again, in the visible from header, they put your CEO's address. DKIM proved the message was signed by attackerdomain.com. Never required a signing domain to match the from address the user sees. So both protocols can pass while the from line is still forged. Each one validates something real, but neither one connects the validation to the address the human actually reads. That missing connection is precisely what DMARC adds, and that's where we go next. So this brings up as to the third layer, DMARC, which is what makes the whole system actually work. DMARC stands for Domain-Based Message Authentication, Reporting, and Conformance. It builds directly on top of SPF and DKIM and adds two things that neither of them has on its own: alignment and policy. Alignment is the key idea, so let's be precise about it. DMARC requires that the domain which passed SPF or DKIM must match the domain and the visible from address that the user sees. That's the connection that was missing. Go back to our attacker from the previous slide. So they passed SPF using attackerdomain.com, but the visible from said your company. Under DMARC, those two domains don't match, so alignment fails, and the whole check fails no matter what SPF technically passed. Same applies to DKIM. If the signing domain is in the D tag doesn't match the from domain, alignment fails even though the signature itself was valid. This is the mechanism that finally stops the spoof. And alignment comes in two modes: relaxed alignment. The default allows subdomains to match the parent. So mail from marketing.yourcompany.com aligns with yourcompany.com. Strict alignment requires an exact match. DMARC passes if at least one of SPM or DKIM passes and is aligned. So you have two independent paths to success. The second thing DMARC adds is policy, which is your instruction to the world about what to do with the mail that fails. There are three policy values. P equals none means monitor only. Nothing gets blocked, but you receive reports. This is always where you begin because you need to watch your mail flow before you start blocking anything. P equals quarantine means sending mail to the spam or junk folder. And P equals reject means refuse it outright so it never reaches the inbox at all. You move through these three in stages and we'll see exactly how on the next slide. Let's look at how you actually configure DMARC because this is what you will publish in your DNS. DMARC record is a TXT record and it always leaves at a specific address. That underscore prefix is deliberate. It keeps this record from being confused with anything else in your DNS. Now look at the three records on screen because they represent three phases of proper DMARC rollout and the order matters. So you never start at the strict end. The first record is the monitoring phase and P will be set as none. And the important part here is the RU attack, which stands for reporting URI for aggregate reports. And it's an email address where the daily report gets sent. In this phase, nothing is blocked. So you're purely collecting data. And the reason this phase exists is that almost every organization is sending email from more sources than they realize. Your own mail servers, Microsoft 365, your marketing platform, your help desk system, your CRM, and whatnot, right? So the reports reveal all of them. So you stay in this phase typically for a few weeks until you have identified every legitimate sender and made sure they all pass SPF and DKIM with alignment. The second record is the quarantine phase. So that is P equals quarantine. Now, failing mail goes to spam. Notice that the PCT tag, which stands for percentage. So PCT equal 25 means apply this policy to only 25% of failing messages, which lets your role enforcement out gradually and watch for problems before you commit fully. And the third record is full enforcement. And we said P is equal to reject. That means any messages claiming to be from your domain that fails DMARC is now rejected outright and never delivered. Now let's put all three together and see the complete sequence a receiving server runs through every time an email arrives. This is the whole system in order. Step 1 is the SPF check. The server takes the IP address of whoever delivered the message and looks up the SPF record for the domain in the envelope. If that IP is an authorized sender, SPF passes. Step 2 is the DKIM check. The server reads the DKIM signature header, pulls the public key from DNS using the selector, and verifies the signature against the message content. If the signature is valid and nothing was altered, DKIM passes. And step 3 is DMARC alignment. This is where DMARC decides whether those passes actually count. It compares the domain that passed SPF or DKIM against the domain in the visible from address. If they align, this step passes. This is a step that actually stops spoofing because it ties the authentication back to what the user sees. Step 4 is the DMARC policy. Based on whether alignment passed and on sending domains published policy, the server decides what to do. Deliver it, send it to spam, or reject it. The single most important thing to take from this slide is that DMARC does not replace SPF and DKIM. It depends on them. SPF and DKIM do the actual authentication work. DMARC checks their results for alignment and then enforces a decision. Remove any one of the three and the system has a hole. SPF alone can be bypassed, DKIM alone can be bypassed, and DMARC has nothing to evaluate without the other two. So all three together is what gives you real protection. Let's take everything we have covered and apply to three situations you will actually run into because the theory only sticks once you've seen it in practice. The first situation is most common. You're running in Microsoft 365. For SPF, you add include spf.protection.outlook.com to your domain's SPF record, and Microsoft maintains that record for you. So it always reflects your current setting service. For DKIM, you go into Microsoft 365 Defender portal, find the DKIM settings, and enable sign-in for your domain. Microsoft generates the key pair and publishes the DKIM record for you. For DMARC, you start at p equal none with the reporting address, watch the reports until you confirm all your M365 mail is passing and aligned, then move through quarantine to reject. The second situation, a third-party platform sends on your behalf, like a marketing tool such as MailChimp. This is where people get caught. You have to authorize them in two places. In SPF, you add their include statement, and separately for DKIM, you configure signing inside their platform, which usually means adding a CNAME or a TXT record they give you to your DNS. If you only do SPF and skip DKIM, their mail can still fail DMARC alignment. So both have to be set up. The third situation, you're reading your DMARC reports and you find a source that's failing. So you have to work it methodically. Check the failing IP. Is it a legitimate service you simply forgot to authorize? If so, add it to SPF and set up the DKIM. Is it signing with DKIM at all? If not, configure it or ask the vendor. And once every legitimate source is passing and aligned, that's your signal that it's safe to tighten the policy from none to quarantine to reject. That progression, driven by what the reports actually show you, is how a real deployment is done. Let's talk about DMARC reports in details, because this is where a lot of people get stuck, and the reports are the entire feedback mechanism that makes a safe rollout possible. When you set p equals none and provide a RDO address, you start receiving aggregate reports, typically once a day, sent as XML files. XML is a structured text format, and honestly, the raw files are hard to read by eye, which is why most people feed them into DMARC reporting tool. Look at the structure you see on the screen so you know what the data actually contains. Each record block describes one sending source. The source IP is a server that sends the email. The count is how many messages came from that source claiming to be your domain. Then the policy evaluated section shows whether DKIM and SPF passed, and the disposition, which is the action what was taken. Here's the detail that confuses a lot of people. While you are in p equals none, the disposition always shows none, even for the mail that failed, because you have told the world not to act yet. You're only collecting data at this stage by design, and the header from the from field shows that domain that appeared in the visible from line, which is what alignment is checked against. So when you're hunting for in these reports is straightforward. Every one of your legitimate sources should show SPF or DKIM passing with a header from that aligns your domain. The row that needs your attention are the ones where a source is failing alignment or both SPF and DKIM are failing. A failing source might be a real service you forgot to configure, or it might be someone actually attempting to spoof your domain. Either way, the reports is how you find out. One limitation to know, aggregate reports tell you sources, volumes, and pass or fail results, but not the content of the messages. If you need per message detail, you would use forensic reports to rough tag, though many organizations leave those off for privacy reasons. Before we wrap up, let's go through the 5 mistakes that most commonly break email authentication, because knowing these in advance will save your hours of troubleshooting. The first, multiple SPF records on one domain. The rule is 1 SPF record per domain. If you have 2 TXT records that both starts with v equal SPF1, receiving servers cannot decide which one is authoritative, and the result is a permanent error that fails SPF for all of your email. Always check that you have exactly one. The second, exceeding the 10 DNS lookup limit in SPF. We covered this earlier. Every include costs 1 lookup, and stacking up Microsoft 365, Google, a marketing tool, a help desk can cross 10 quickly. Past 10, you get a permanent error. The fix is SPF flattening, which uses tools that resolve all those include down to explicit IP ranges, so the lookups disappear. The third, jumping straight to P equals reject. The monitoring phase exists for a reason. Every organization has forgotten centers, and if you enforce before you have found them, you'll start rejecting your own legitimate email. Always spend real time at P equals none first. The fourth, configuring SPF for a third party sender before forgetting DKIM. Adding a service to SPF is not enough on its own for DMARC. If that service doesn't also assign with DKIM aligned to your domain, its mail can still fail alignment. SPF and DKIM give you two paths to passing, and you want both wherever you can. The fifth is ignoring the DMARC reports entirely. The reports are your only real visibility into what's being sent under your domain name. Deploy DMARC and never read them, and you have no idea what's passing, what's failing, or whether someone is actively impersonating you. These reports are not optional paperwork. They are the core of running this properly. Let's bring it all home with one mental model that ties the three together so you never mix them up again. SPF answers who is allowed to send. It's a public list in DNS of the servers permitted to send email for your domain, and receiving servers checks the sending IP against it. DKIM answers was the message tampered with. It's a cryptographic signature that proves the message was authorized by the domain and arrived unchanged, verified using a public key published in DNS. DMARC answers, does it match what the user actually sees? It checks that the domain which passed SPF or DKIM aligns with the visible from address, and it tells receiving servers what to do when something fails: monitor, quarantine, or reject. And the reason all three matter together: SPF on its own can be bypassed by forging the visible from. DKIM on its own can be bypassed the same way. DMARC on its own has nothing to evaluate. Put them together and you have a complete system that makes it genuinely hard to impersonate your domain, improves your deliverability because mailbox providers trust authenticated mail, and gives you full visibility into everything sent in your name. That's email authentication.